Today's lecture is on section 1.3, and this is the classification of matter. There are two main forms of matter, pure substances and mixtures. In this slide, we're going to take a look at only pure substances. A pure substance is considered to be matter that is the same throughout. It's made up of the same kind of matter. There are two kinds of pure substances that exist. Elements are pure substances that are made up of only one type of matter, meaning one kind of atom. Compounds, on the other hand, are pure substances made up of two or more kinds of matter that are chemically combined together. This would be two or more different kinds of atoms bonded together. You can think of sodium chloride as being a compound. It is made up of sodium atoms and chlorine atoms. Let's take a look at elements first. What I want you to notice here is the different examples of elements. Up here in the upper left-hand corner, I drew 5 circles here. This represents the exact same type of element in a cluster of atoms, which is an element. Another form of element is a special type called a diatomic molecule. Diatomic molecules are when atoms of the same element, notice that these guys are the same type of element, when they're bonded together. This is not a compound because it's the exact same element bonded to itself. We call this diatomic. A second special type of element is what we call an allotrope. Both diamond and graphite are made of elemental carbon. However, due to different pressures and temperatures, they form differently. I personally would rather have the diamond, not sure about you. Let's take a look at this periodic table that I pasted here. I like this periodic table because although the symbols are there and they're tiny, I get that, you at least get to see real-life examples of what each element looks like. If we take a look on the right-hand side, we have a whole bunch of non-metals here. We've got oxygen and fluorine, nitrogen, sulfur. And then look right here, these are what we call the noble gases. And helium, neon, argon, krypton, and xenon can all be used in glass tubing to create what we call neon lights, although the only true neon light is a light made with what appears to glow with red color. There's copper over here, and if you kind of look, we start to get shiny right along this diagonal here, and that will become more important as we learn about the periodic table later in the year. All of these tend to be more shiny, and those are all considered to be metals. Here are some examples of compounds. We have magnesium chloride, which is a white powder, and you'll learn throughout the year that most ionic compounds are white powders. I also included 3 pictures at the atomic level to show you the different sizes of the elements and how they're bonded. So first up is water. We all know water is H2O. So we have 1 oxygen in the center and we've got 2 hydrogens off to the side. Ammonia has a nitrogen atom bonded with 3 hydrogen atoms. And carbon dioxide has 1 carbon atom with 2 oxygen atoms. Notice that in all 3 of these examples, the atoms are bonded to one another. That's what makes a compound a compound. The second type of matter that we're interested in is what we call mixtures. Mixtures are when we have substances that contain 2 or more types of matter that are physically combined. Mixtures can be made up of elements, compounds, or a combination of elements and compounds. There are 2 kinds of mixtures that we will encounter throughout the year: homogeneous mixtures and heterogeneous mixtures. You've heard the homo and hetero prefixes in your biology classes when you were talking about homozygous and heterozygous. The prefixes mean the same in chemistry. A homogeneous mixture is one that is the same throughout. It has one phase. You can no longer see the components individually. We call these mixtures solutions. Heterogeneous mixtures have two or more phases that you can visually see. And in the next slide, I've got some examples to show you exactly what I mean by homogeneous and heterogeneous. Here we have a number of examples of homogeneous and heterogeneous mixtures. On top, we've got 3 examples of homogeneous mixtures, otherwise known as solutions. The first I'd like to show you is our trumpet right here. This is a brass instrument. Brass is a special solution. It's a solution of metals. Zinc and copper have been mixed together to produce what we call brass. We call that an alloy. Alloys are mixtures of metals. I put in a favorite, our Kool-Aid Man, because Kool-Aid is a solution. You mix the Kool-Aid powder and water together, and it forms a single phase after you've stirred it. You can no longer see the difference between the water, the sugar, and the dye in the Kool-Aid. Coffee is also considered a solution. Although you do filter out the coffee beans, you can no longer distinguish what is coffee and what is water inside this mug. Heterogeneous mixtures contain more than one phase. You can think of chicken noodle soup. I know you can imagine the noodles, the chicken pieces, and the broth. No matter how well you mix the 3 together, you will always be able to distinguish each phase in the soup. I put in a picture of milk in because while we may think that milk is a homogeneous mixture because it looks the same throughout, technically speaking, when you zoom in and get closer to an atomic level, not quite the atomic level, but close to it, you can see that milk is a heterogeneous mixture. This is a tough one, but students are still expected to know that milk is not a homogeneous mixture, but rather it is a heterogeneous mixture. In this next example, I want you to look right here inside this beaker. We've got one phase right here that's a little gray and one that's more cream. And I believe this is some liquid here. So we possibly have 3 different phases in this beaker. Clearly, these 2 did not mix well. We have a heterogeneous mixture. Finally, one more real-life example of a heterogeneous mixture, and that's fruit salad. No matter how much you mix the fruit, you can always tell each different kind of fruit from the other. I put this slide together so that you have a flow chart in order to be able to classify a sample of matter that you're given. I would really like you to copy this down in your notes so you have it as a quick chart in order to decide how to classify a sample of matter. Let's recap. Matter can be classified as either a pure substance or a mixture. A pure substance is the same kind of matter throughout the entire sample. If you determine that you have a pure substance, you have to further classify it as either being an element or a compound. An element contains only one type of atom throughout the entire sample. If you determine that you have an element, you must decide if you have a special type of element. Remember, diatomic elements are when 2 atoms of the same element are bonded together. Allotropes are when an element can form more than one kind of matter. For example, again, carbon can form various allotropes. It can become a diamond, or it can become graphite or charcoal, depending on the pressure and the temperature under which the carbon atoms come together. If your sample of matter is not pure and rather is a mixture, you then have to take a look at the kind of mixture you have. If your mixture has only one phase, meaning everything has been distributed in such a way that you cannot distinguish between the components of the mixture, you have a homogeneous or something that we call a solution. If the mixture has two or more phases that you can clearly distinguish, such as fruit salad, or different layers of liquid sitting on top of each other refusing to mix, then you have a heterogeneous mixture. I hope that this discussion helps you understand how to classify matter better.